This Chem Catalyst video is on writing equations for precipitation reactions. And you know what? I don't have a joke for you in this one. And you know why? I'm just not sure that my chemistry joke today would get a good reaction. Think about it. All right, today we're talking about solid evidence, and this Chem Catalyst video is going to really be talking about solubility and equation writing. So let's take a look at this equation here between sodium chloride and silver nitrate. Both of these compounds are highly soluble. They're aqueous, means that they dissolve in water. But when we react these two things together, we end up getting what's called a solid, which goes by the name of a precipitate. All right, and precipitates are solids that are produced when two chemical reactions are produced. This one happens to be, if you go back and take a look, this one happens to have the chemical formula AgCl. So the AgCl that we're looking at here is not aqueous. It is a solid because it has formed when those two chemical compounds, in this case sodium chloride and silver nitrate, react. Now, typically we get precipitation reactions and they result from mixing two aqueous salt solutions. Like in this case, we mixed aqueous sodium hydroxide with magnesium nitrate. Here are the reactants on the balance. And keep in mind these would be equal to each other because we're just taking this beaker and literally dumping it into that beaker, and we end up with some solid at the bottom. Now, the solid doesn't look like bricks in this case. It's not going to look like, solid rocks, but it is going to be a fine crystalline powder, and we know that that has produced a solid. So what we want to really try to do today is be able to write some of these precipitation reaction equations. So here's our practice slide today. What you really want to do is I want you to write and balance the following reactions. So we need to go back to a lesson that we did quite a while ago when we talked about double exchange reactions. In a double exchange reaction, we swap cation for the other anion and cation for the other anion. But before we do it, we have to identify charge. So you either need to know your polyatomics or common charges using a periodic table. But the charge on sodium is a +1, chlorine is a -1, or chloride, silver is a +1, and nitrate, which is a polyatomic, is -1. So since the charges are all 1, my product's pretty simple. In this case, it becomes NaNO3, and that is the aqueous product. And the other product is AgCl. And this is the solid, and we observe this in lab. That's why we know this is solid. We're not using solubility rules here. We just know that this is the solid because I said up here the products containing sodium in this case will be aqueous. So down here we got a little bit of a different story though, because the sodium here is still a +1, chloride is still a -1, but over here the nitrate's a -1, and there are two of them. So that means the copper has to be a +2 charge. So let's go ahead and swap cations and anions. This goes over here, this goes over here. And you'll notice here that we have a NaNO3 as one of the compounds that is produced. And the other compound is going to be between the copper and the chloride. But notice, +2 and -1. So we need CuCl2. This is going to be our solid. Now, a lot of you are probably cringing right now thinking, but wait, the equation's not balanced because I have one copper here, one here. Well, that looks balanced, but look, I have two nitrates here and only one here. Well, this is where we have to go through and balance putting in coefficients. So I put a 2 in there. That balances my nitrates. And then I go ahead and I put a 2 here, which balances the sodiums. See, 2 here, and chlorides, 2, 2, 2, and 2. Perfect. Now our final one here, cation, sodium hydroxide is +1, hydroxide is -1, copper +2 again, -1 for the nitrate again. So again, copper goes after the hydroxide, sodium goes after the nitrate. So again, we're going to have NaNO3 as one of our products, which will be aqueous. And then the other product will be copper 2 hydroxide, right? Because copper's a 2 plus, hydroxide's a minus 1. We need 2 of them to balance out. That equals 0 up here because, 2 plus minus 1 times 2, 0. All right, and we need to go back and balance the equation. So to balance the equation, I'm going to need 2 of these, 2 NaOHs, and I'm going to need 2 NaNO3s. No, 2 NAs, 2 NAs, 2 hydroxides, 2 hydroxides, 1 copper, 1 copper, everything is good. Time for your checking question today. A solution of potassium sulfate, K2SO4, is combined with a solution of lead nitrate, PbNO32. Guess what? We get a solid. I want you to write the balanced chemical equation for this reaction. Press pause and then check out the solution. Well, here's our equation, folks. K2SO4 aqueous combines with Pb lead nitrate, which happens to be aqueous. And our products are, let's see, the lead has a +2 charge, sulfate has a -2 charge, so it's going to be PbSO4, and NO3 -1, K +1, KNO3. Now, this is our solid. This is what's aqueous. Okay, and some of you might have wanted to write K2NO32 because of this 2 and that 2. But remember, this is a +1 charge. This is a -1 charge. This is the product, KNO3, because it's +1, -1. To balance, that's where I'm going to go in and put a 2 in here because now the equation is balanced. 2 Ks, 2 Ks. 1 sulfate, 1 sulfate. 1 lead, 1 lead. 2 nitrates, 2 nitrates. And we now know how to write the products and balance precipitation reactions.